Hello everyone. Today we will be talking about X-ray production as well as the two main target interactions that create X-ray photons in the X-ray tube. So here we go. There are three requirements for X-ray production. The first one is a source of electrons. The second is a way to accelerate those electrons. Third is a way to decelerate those same electrons. Electrons are produced in the X-ray tube and at the cathode filament by a process called thermionic emission, which is the role of electrons in response to heat. A current running through the filament causes it to be extremely hot, and electrons dissociate from the metal and form an electron cloud around the filament. Bremsstrahlung radiation. So here's a fun fact. Bremsstrahlung is in Deutsch ein word für brechenden Strahlung, which means in German, breaking radiation. A tungsten atom has a positively charged nucleus because of its protons, and it's surrounded by negatively charged electrons. All of these charged particles have an electric field that radiate around them. When electrons from the cathode enter the anode, some electrons are attracted to the nucleus positive charge within these tungsten atoms. As this happens, the electrons slow down or break, and they also change direction. That lost energy is released in the form of an X-ray photon. Characteristic radiation. Characteristic radiation is another form of interaction that creates X-ray photons. An electron from the cathode collides with the inner shell electron in the tungsten atom. This electron gets knocked out of its orbit and leaves a vacancy in the inner shell. The vacancy makes the atom unstable. Therefore, an electron from the outer shell will quickly drop in to fill the void, creating something called cascade effect. When the electron drops from the outer shell into the inner shell, it releases energy in the form of a characteristic X-ray photon. The X-ray photons created have specific or characteristic energies to the electron shells and atom type. Characteristic radiation is affected by kVp. Increasing the kVp will result in an increase in the number of characteristic radiation, but it will not change the energy. If the kVp is decreased, the number of characteristic X-rays will also decrease, but there will be no change in its energy. In summary, X-rays are produced by three basic things: a source of electrons through thermoionic emission, a means of accelerating electrons, and a method of decelerating these same electrons. The MA is used to control the number of X-rays, and the kVp controls the energy of those X-rays. In summary, X-rays are produced by three basic things. One is a source of electrons through thermionic emission. Number two, a means of accelerating these electrons. And number three, a means of decelerating those same electrons. We also learned that Bremsstrahlung radiation and characteristic radiation are the two most important types of radiation energy in the production of X-ray. So, thank you very much for watching.